Is that clear?
Yeah,
So this
thank you, Prof.
dah faham dah?
Okay.
Alright. Now let's look. Now let's go over the tutorial. Yeah. Now you please take note of your tutorial. Yeah. Saya nak sementara saya padam ni. You get ready with the tutorial. Yeah. Betul lah, sekejap nak padam ni. Okay. Let's look at tutorial 1. Okay. Alright. So look at tutorial 1. Have you done the tutorial or not? Have you tried?
Yes.
Please answer me. Okay. So if you have done number 1, what do you get? Let me check my answer. Okay, what is number 1?
0.00027.
Okay. So yeah. So how you do this? If please note, yeah. To do this question, you first note what is the first you need to find what first you need to find. You have to find the CDF, isn't it? FX. Yeah, always remember. Always try to find the CDF of X. Yeah. Then you substitute in the formula, isn't it? What you want here to find GY3, right? So you just then when you I think once you have done this, I just give you the answer. Yeah? The answer should be 0. My answer here 0.0000026, right? 2699 something, right? Do you get this or not? Well, it's close, right? It's close. Dot. Or you can just say 0.0027. Everyone get this or not?
Dapat, Doktor.
Dapat?
Dapat.
Yes. Okay, then find the probability of Y3 greater or equal to 5. Well, yeah, this is the probability, right? Number 2. Number 2. Number 2, what is the answer for A? Everyone get the answer A or not? Answer B. B.
No.
Huh?
Because integrate fx is not equal to 1.
Okay, yeah. So I think the rest, I just want to highlight here. Yeah. What I want to highlight here is that for this number 2, you cannot get the answer. Yeah, I just want to put it here so that you know why there's no answer for this number 2. Yeah. Why there's no answer for number 2 is because this is not a PDF function. Yeah, this fx is not a PDF function. If you look at the theorem 2, how to get the probability for the ith order, probability of the order statistic, you need a random sample of size n with a PDF function fx. Now look at this. Is this a PDF function? Please answer me. Is this a PDF function? Dengar saya tak? Hello? Sekarang you all senyap je, saya ingat dah tak ada dah. So this is this a PDF function? Jawab aje lah. Tak ada orang nampak pun siapa yang menjawab tu. Jawab je. Is this a PDF function?
No.
Yeah.
Okay. Amy, why this is not a PDF function?
Because it's not equal to 1.
What not equal to 1? Cannot just say not equal to 1. What not equal to 1?
Integrate the
Ah,
function
so
from 0
if
to
you
1.
the condition for the PDF function fx must be here. When you integrate this, right? With respect to what? With respect to what? With respect to
X.
yeah, yeah, 0 to 1. Will you get for a PDF function when you integrate the function with respect to the interval given should be equal to what? Should
Equal
be
to
equal
1.
to what? Be equal to 1. But for in this situation, I mean for this example, it's not equal to 1. So this is not a PDF function. And did you see or not my cursor here when I write here? Did you see my cursor here?
Can.
Boleh nampak kan? Nanti saya shot sendiri macam ni. Okay. So this is not a PDF function. In this respect, we cannot find the probability. Okay. All right. So now let's move on to number 3. Number 3. Number 3, what is the answer? Let me find my answer first. Expected value, well, if you get GY2 correct, then your expected value should be correct. What is the expected value of Y2?
1
What
over 3.
You should get 1 over 3. Yeah. If you get this 1 over 3, meaning that here you get it correct already. Yeah. Okay. All right. All right. Next, let's look at number 4. Padam dulu. Okay. Number 4. Number 4. Independent exponentially distributed random variable with mean beta. Show that y1, the minimum has an exponential distribution with mean beta divided by n. Have I done this or not? Number 4a, I think I already done this in class, isn't it?
Yes.
I've done this in class. Yeah. So you refer to the class example where I have done this in class for A. For B, if n equal to 5 and beta equal to, this one I have not done in class. Find the probability of y1 less or equal to 3.6.
0.99988.
Okay, let's see what do you get here. So here, if you have done this correctly, then this will be 0.999987 something, right? 876 dot. Okay. Okay, so yeah, so you should get this value. Where how you get this value? How do you get this value? You integrate the function, right? You integrate 5 over 2, isn't it? 5 over 2. Because given n equal to 5, then e to the power of what? Minus 5 over 2, isn't it? Minus 5 over 2. 5 over 2, y1. This is 5. Tak nampak sangat ni. Susah nak tulis ni. 5 over 2, y1. dy1. dy1. From 0 to what? 3.6.
3.6.
Okay. So you should get this when you integrate. Okay, next. Next, we move on to number 5. Jam dulu. Okay. Okay. The opening price per share Y1, Y2 of two similar stocks are independent random variable, each with PDF given by this. Okay. Okay. On a given morning, an investor is going to buy shares of whichever stock is less expensive. Yeah, because you only have two shares. Yeah, the one that is less expensive. Yeah. So meaning that what do you want actually here? Find the PDF for the price per share that the investor will pay. The investor will pay what? Which stock? Which shares? Which is less expensive, isn't it? Which is less expensive. So meaning that you want to find the, because you have only two, meaning that you want to find the first order statistic, isn't it? Find the PDF, the PDF. Yeah. So you want to find G1, Y1. Well, here because this Y already been used, I already used this as a random variable. Yeah. So yeah, I'm afraid that you get confused with the symbol here, the X, Y1, Y2. Yeah. So this is actually, if I mean any variable Y1, Y2, then here the PDF, or let's say you say the first order statistic you use as U. Yeah. So you just write what when in the test or what you just write. I use the symbol U as a order statistic, U1, U2, dot, dot, UN. Yeah. So, yeah. Then the PDF for the price per share probability of U equal to. So what is the probability of U? You have to first mention to me because why? Because I am afraid that you think that if I write Y1, Y2, this is order statistic. No, not yet. Because this is just a random variable Y. Yeah. So now, PDF of the price per share that investor will pay, because you have two only, so you have U1 and U2. Let's say I said U1 is the first order statistic, U2 is the nth order statistic. What I want here is the U1, the first order statistic. Yeah. So what is G1? What is G1, Y1? Well, before that, I just want to ask you whether you get the expected cost per share.
5.
Anyone has done this? You should get 5, right? You should get 5 here. Yeah?
Yes.
The expected value is 5. Yeah. So the PDF, well, I just want to highlight, whenever you do this to find the PDF or the any other statistic, first, you have to, if the original variable is in term of X, is okay. You can use the order statistic as Y. But if the original observation PDF is already given as Y1, Y1, Y2, dot, dot, YN, then the PDF of the ith order statistic, you may use other symbol or other letter, such as U. Okay. And also I want to highlight that there are two ways how to find the PDF or the for the first and the nth order statistic. There are two ways to do this. You may use theorem 2, to get the PDF for the first and the nth order, or you may use the CDF technique. The CDF technique, remember the CDF technique to find the first G1, Y1, yeah, and also the nth order. Remember this N, YN, or you don't have to write N is okay, YN. So you may use, for this you may use what? To find the first and the nth order statistic, there are two ways to do this. One way is to use the theorem 2, right? There is a formula. The second way, how to use the second technique? The second technique is to use the CDF technique. Everyone remember or not the CDF technique? Please answer me the CDF technique for to find G1 and Gn.
Yes.
Okay. Now, please note if in the question, if doesn't mention whether you used to use whether you were asked to use CDF technique or the theorem 2 technique, so if it is not mentioned, it's up to your choice. You may choose either one. But if I specifically mention that you have to use the CDF technique, then you use the CDF technique to answer the question. Please take note on that. Is that clear? Yeah.
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 Alright. Dam dah. Okay, so however, for both technique, the first step what you need to do, very important. For both technique, what you need to do in the first step? Whether you use a CDF technique or theorem 2, the first step you need to get the, always remember, always get the CDF, right? Always get the CDF for X, the original random variable. Always start with this. Always start with this. You get this first, the CDF. Yeah. Okay. Okay. Next, number 6. 10 points are chosen randomly and independently on the interval 0, 1. Yeah. Find the probability that the point nearest 1 exceeds 0.95. So, well, let me first ask you, did you get the answer for the probability that the point nearest 1 exceeds 0.95?
0.4013.
Okay, you should get here 0.40, jauh pula dah, 13. Okay, you should get 0.4013, the answer here. Yeah. So if you notice here, 10 points are chosen and independently on the interval 0, 1. Yeah. So meaning that these 10 points are randomly within this 0, 1, meaning that fx is a uniform distribution. So fx should be equal to 1. Yeah, uniform. Then you have to find the capital of fx. Yeah, capital fx. Yeah, equal to x, right? Then you find the probability that the point nearest 1. So meaning that you have 10 point nearest 1, meaning that that is the nth order statistic. Yeah, so you want to find the G Y10. GY10. Yeah. Then after that, once you get this, you try to find the probability that exceeds 0.95, then you integrate this. Yeah, to those who have not done this. Integrate exceed 0.95, meaning that you have to integrate 0.95 to 1. Because x is between 0 and 1. Okay. All right. So, well, okay. You also have to remember beta distribution. Yeah. Sometimes it's easier to, if you notice that x is if x have interval between 0 and 1, if you notice that, and then you have to remember what is the beta distribution, then you need it's easy for you to to simplify the integration using the beta distribution. Yeah. So here number 6, you can make use of the beta distribution to answer this question number 6, because this is the interval x between 0 and 1, and so on. Yeah. So you have to remember, look at the beta distribution function, how to integrate easily using the beta distribution. If you notice that the function is a beta distribution. Yeah? If the function is between x between 0 and 1, and then the function in this, the function of beta, if you look at the function of x like this, fx equal to gamma function. Remember this gamma function, alpha plus beta, alpha plus beta. So here, gamma function alpha, gamma function beta. Yeah, and then here x, alpha minus 1, and 1 minus x, 1 minus x. Okay. Yeah. Okay. One minus x. Yeah. 1 minus alpha, beta minus 1. So x should be between 0 and 1. If you have, if you see a function, in this form, then an x between 0 and 1. So in order to integrate this function with respect to the interval here, it's easier to match this with the beta distribution. Look at my notes. Look at my notes how to deal with this problem. Yeah. Okay. Any question? No. If no question, we move on to the next. The padam dulu. Ni senang kat sini padam kat sini. Tak perlu nak pakai. Okay. Alright. Okay. Next, we move on to tutorial 2. Tutorial 2. Okay. Okay. So tutorial 2, I think not much problem, right? Tutorial 2, what is? Can you conclude there is a non-random pattern of overfitting and underfilling such bottles? So H0, always you write there's a random pattern. H1, not a random pattern. Yeah. So what is the run here? What is the R? What is R equal to?
7.
7.
R equal to?
7.
7, right? 7. And then N1, so the at 5% significant level, so the lower interval, we denote as W, right? We denote W 0.025, 0.25 equal to what? Equal to what?
5. 5.
0.25? Is it 5?
5.
Next.
6.
Yeah.
To be what? 5 or 6? At 0.025, because you have to divide this equally, because this is, you have to divide this by 2. Yeah, so here should be 6. Should be 6, and the upper limit, upper critical value should be what?
14.
14. So is it reject H0 or not to reject H0?
No.
Alright, so there is a random pattern. Okay, now we move on to number 2. Erase first here. So for this, Number 2, yeah. So what is your R?
5.
R equal to 5, isn't it? Yeah, 5.
5.
Lower interval, lower critical value equal to
7.
1, and the upper is 15, right?
Yes.
So reject or not to reject H naught?
Reject.
Reject H naught. Okay, so reject H naught, number 2. Number 3, compute probability R greater or equal to 4. Have you done this or not, number 3?
Yes.
So what do you get?
0.79997.
Number 3 should get, okay, what did you say just now?
0.79997.
0 point
7.
7
9997.
9997.
Ah,
So,
999.
and then satu lagi.
Ah,
Okay, any other question answer? Any other answer or not here? How do you do that? Amy, what do you get?
I didn't do.
You didn't do. Okay. So the answer is not that correct. Yeah? Because probability R greater or equal to 4, this equal to, should be equal to 1 minus probability of R less or equal to what? R less or equal to what?
3.
3, isn't it? 3. So this is equal to 1 minus probability of R equal to, you all ada kelas ke pukul 10? Ada kelas ke pukul 10? Oh, tak ada kelas? Ada?
Tak ada.
Ada?
Tak. Tak.
Okay, tolak. Okay, memang tak ada lah tu. R equal to 1. Equal to 1. Tolak probability R equal to 2, right? 2 minus probability of R equal to 3. Okay. Now look at probability R equal to 0. First look at the probability R equal to 0. Is it possible to have R equal to 0? Possible or not to have R equal to 0?
Not
No.
possible.
Not possible, right? The first that you should have, the first run should have 1, right? The smallest one is 1, right? So R equal to 1. Yeah. With R equal to 1, what is R? When R equal to 1, what is the value? There are to find probability R equal to 1, you use the which formula? The second formula, isn't it? Where probability R, yeah, Probability of ini susah betul nak tulis lah ni. R equal to 2 new plus 1. Betul tak? To find probability R equal to 1. You make use of this, isn't it? You make use of this. Nampak tak cursor? My cursor here.
Yes.
Nampak.
Nampak.
Use of this, isn't it? So to have R equal to 1, mu should be equal to mu should be 0, isn't it? 0. Then mu should be equal to 0. Now you look at your the formula. Now look at the formula because it's very difficult to write here. Takes time to write. So everyone look at the formula. You look at your notes how to write this formula. Now I just just mention this. So for R 2 new plus 1. So you look at your formula and 1 minus 1. The first part there, the first term, and 1 minus 1 and 1 equal to 3. 3 meaning that 2. Combination of 2 take new. What is new? 0, right? Combination of 2 take 0. Multiply by. And 2 equal to 4. 4 minus 1, 3. Combination 3 take new. New 0. 0 minus 1. 0 minus 1 is what? Minus 1 is so anything when you take negative, combination of 3 take negative 1, so that will be 0. Plus, plus and 1 and 1 3 2 minus 1. So 2, 2. So 2 take new. New is 0. 0 minus 1 is minus 1. So anything, any number, combination of any number takes negative, so also 0. So for this, so meaning that for this whole thing equal to 0. So what left is just 1 minus, what left is just dibuang. So 1 minus probability R equal to 2 minus probability of R equal to 3. When you simplify, nanti nak tanya dulu. Tadi siapa yang dapat jawapan ni tadi? Siapa yang jawab ni tadi? Tak ada masalah, jawab aja, tak ada ni.
Saya doktor.
Tak ada potong markah pun, jawab aja.
Saya doktor.
Okay,
Saya
you buat tadi? You buat macam saya buat tak?
Saya guna tak.
So you should do like this. So after what left is just 1 minus probability R equal to 2 minus probability R equal to 3. When you simplify, what you should get, so you should get 4 divided by 5. Kalau betul lah saya calculate ni. So after you subtract probability R equal to 2, subtract probability R equal to 3, you will get 4 divided by 5. So the answer should be 0.8. Okay? Okay.
Okay.
Jawablah. Jawab tak jawab susah lah. Saya takut saya cok sendiri, rupanya you all tak dengar. Okay. Okay, saya padam ni. Alright, okay. Now move on to the number 4. Number 4. What is okay? 6 assessment. Dollars rank. Lepas tu soalan dia, perform the run determine whether the dollars rank of the plastic differ in location. For this example, for this problem, how do you state your hypothesis? Are you testing whether there's a random or not random?
No.
No, right? So for number 4, if you remember when I mentioned during this class, during the run test, I already mentioned that the run test, even though it is less powerful, can be used to test whether two samples come from the population with the same distribution. When two samples come from the same distribution, meaning that their medians are equal. So you may write that both samples come from the same distribution, or you may write in term of So you may write this in term of H naught. If both samples come from the same distribution, so meaning that their median is equal. So M1 equal to M2, MH1, they are not equal to M2. So you may write your hypothesis in terms of median, or you may write your hypothesis in terms of saying both samples come from the same distribution. H1, both sample doesn't come from the same distribution. Or you may write in this fashion. This run test can be used to test this hypothesis even though it is less powerful. Okay. So if you do that, so what is your R? What is your R?
6.
R should be 6. So R should be 6. What is the lower critical value?
3.
3, right? And the upper critical value? 9.
9.
So, fail or not to reject or not to reject H naught?
Not reject.
Fail to reject H naught. All right. So next, number 5. Mana ni? Okay, number 5. About the okay. Sekejap ya, kita berhenti sekejap. Berhenti sekejap lah ya. Kita berhenti sekejap. Ambil 5 minit. Take 5 take 5.